Hello everyone, this is Niharika from Sri Venkateshwara College of Engineering. Here is my subject, that is data structures. Let us move on to our topic. Here is the topics: what is binary tree traversals, what is graph and types of graphs, that is directed graph, undirected graph, complete graph, subgraph and path cycle. Let us see what is binary tree. A binary tree in data structure is a hierarchical data structure in which each node has at most two children, referred to as the left child and the right child. It is commonly used in computer science for efficient storage and retrieval of data with various operations such as insertion, deletion, and traversal. And let's move on to an representation of binary tree. The representation of binary tree has each node in the tree contains the following data: pointers to the left child, pointers to the right child. Let us move on to basic operations of binary tree. Inserting an element, removing an element, searching for an element, and deletion for an element. And auxiliary operations of binary tree as finding the height of the tree, finding the level of the tree, and finding the size of the entire tree. Let us move on to an applications of binary tree. In compilers, expression trees are used, which is an application of binary tree. Huffman coding trees are used in data compression algorithms. Priority queue is another application of binary tree that is used for searching maximum or minimum in zero time complexity. Represent hierarchical data used in editing software like Microsoft Excel and spreadsheets. Used for indexing segmented at the database, which is useful in storing caches in the system. Syntax trees are used for most famous compilers for programming like GCC and AOCL to perform an arithmetic operation. For implementing priority queues. So let us move on to an binary tree traversal. Unlike linear data structures, that is array, linked list, queues, stacks, etc., which have only one logical way to traversal them, trees can be traversed in different ways. A tree data structure can be traversed in following ways: depth first search or DFS, that is in order traversal, pre-order traversal, and post-order traversal. Level order traversal or breadth first search or BFS, boundary traversal and diagonal traversal. Let us move on to tree traversal techniques. Here is a tree traversal and in order traversal, pre-order traversal and post-order traversal. In order traversal, algorithm in order. Traversal of the first subtree. First we will move to the first subtree, then to the root, and then to the right subtree. In pre-order traversal is defined as a type of an tree traversal that follows the root left right policy. That is, the root node of the subtree is visited first, then the left subtree is traversed, at last the right subtree is traversed. Let us move on to an post-order traversal. Post-order traversal is defined as the type of tree traversal which follows left, right, and root policy, such as the left subtree is traversed first, then the right subtree is traversed, finally the root node of the subtree is traversed. Let us move on to graph. What is graph? A graph is a non-linear data structure consisting of vertices and edges. The vertices are sometimes also referred to as nodes and the edges are lines or arcs that connect any two nodes in the graph. More formally, a graph is composed of a set of vertices V and a set of edges. The graph is denoted as G of E, V. Here is a graph given in this picture. That is 1, 2. It is connected. It is connected. 1 is connected to a 2. 2 is then connected to 6. Again 2 is connected to the 4. 4 is connected to 1. 3. 3 is connected to 1. So again 3 is connected to 5. Here are the nodes 3, 1, 2, 4. Vertexes are nodes. And here are the edges which is connected between the 4 and 3, 1 and 2, 2 and 3, etc. Let us see types of graphs. Directed graph. A graph in which each edges has a direction. That is, the edges have arrows indicating the direction of traversal. For example, a web page graph where links between the pages and the directional. Here in this diagram, if you can see here A to B. Here it does not have an arrow mark. If it is having an arrow mark, then it is an directed graph. Undirected graph. A graph in which edges has no direction. That is, the edges do not have arrow marks indicating the direction of traversal. For example, a social network graph where friendships are not directional. You could see here A to B, B to C, C to D, D to A. It is an undirectional graph. Then complete graph. A graph in which each vertex is connected to every other vertex. For example, a tournament graph where every player plays against every other player. You can see here a graph of A, B, C, D. Here A is connected to B and A is also connected to D and also for a C. It is an complete graph connecting for all the vertices and all the edges are connected in all equally. Cyclic graph. For a graph to be called a cyclic graph, it should consist of at least one cycle. If a graph has a minimum of one cycle present, it is called a cyclic graph. You could see in this picture that A is connected to B, B is connected to G, G is connected to F, F is connected to E. It is a cyclic graph. Subgraph. A graph in data structure is said to be a subgraph if it is a part of another graph. In the following example, graph H1, H2 and H3 have a subgraph of the G. If one graph is given and that is having a subgraph of H1, H2, H3, then it is called a subgraph. What is path? It is a trial in which neither vertex or edges are repeated. That is, if we traverse a graph such that we do not repeat a vertex and nor we repeat an edge. As path is also a trial, thus it is also an open walk. So thank you for watching my video.